Dear students, as I have told you in the theory that what we will be doing today, we will be doing the diffraction of light through the glass slab. So, here what has been done, these are the apparatus required, which we will be arranging, and according to the practical. Students, as you can see in this particular practical, the apparatus required are a wooden board, a white page. This white page is this page is stuck with this wooden board with 4 board pins, 1, 2, 3, 4. This glass slab, this is the main requirement for this practical, this glass slab. Excluding this glass slab, we need a sharp pencil, a eraser sharpener, 4 long pins, protector and a scale. First of all, this glass slab is taken over this white page, and outline is done on this page. So, as you can see, I am doing an outline over this glass slab, so that we can draw a perfect ray diagram for this one. So, this has been done first. Now, what we are doing, we are removing this glass slab, and we will be joining the lines in the corner. Now, as we all know, we have to first draw a normal. Now, when we will be drawing a normal, we will be taking help of this protector. With the help of protector, first I am making 90 degree with the surface. Okay. So, if I mark a point 90 degree on this particular point, then I have to draw a normal. This normal I am drawing with the help of a dotted line. So, the normal has been drawn. Now, what we are doing with respect to the normal, we are taking 30 degree, and with 30 degree we are making the angle of incidence. As you can see, with respect to this one, when I am taking 30 degree over here, so at this point I will be drawing a incident ray. So, this will behave as incident ray for me. Now, what we are doing here, with the help of these 2 long pin, as you can see, these 2 long pins, I will be putting on this particular incident ray only. One here, another one here. So, 2 pins I have given. So, these 2 pin will be like incident ray or the source which I will be observing through the glass slab. Now, what I am doing on that marked point, again I am putting this glass slab. Exactly on that point, you should be careful about this thing, that exactly on that outline only you have to put the glass slab. So, first of all, you see this thing, these 2 pins are kept on that particular angle of incidence. What angle of incidence I have taken? This particular angle of incidence I have taken as 30 degree. So, for 30 degree I have taken 2 pins, these 2 pins will be like source for me. Now, what I have to do? I have to see these 2 pin from this side. Okay. So, I will be sitting on this side, and I will be making a level, my eye observation level should be on the glass level, and I have to observe from this side, other side, emerging side of the glass slab. Okay. Now, we will be seeing that 2 pin which we have taken as incident ray, that we will be observing from this side of the glass slab. Now, gradually we are shifting our head from a point to the right side, and ultimately we are seeing that both the pins are visible on a single straight line. Now, as you can see here, that this pin, this is the actual, these are the actual pins, and what you are seeing through the glass slab, these are the lateral shifting of the pins. Okay. So, this much shifting has happened due to refraction of light ray. So, this angle we will be calculating. Now, with the help of pins, what we will do, we will put another 2 pin on this particular position. So, first what we are doing, we are observing this thing, and we are putting this pin on that particular straight line where you are seeing the emergent ray is coming out. Now, here on this particular point we are putting first pin. So, one pin has been done here, and another pin we are taking on the same straight line, and we are putting on that particular position only. So, by observing that all the pins, that means these 2 pins what we are putting right now, and the images of that 2 pin which is seeing through the glass slab, they all should be lying in a same straight line. This is our task. Now, when these 2 pins has been given at this emergent side, now what we will do, we will remove this glass slab. Now, we will mark these 2 points, these 2 points we will be marking with the help of pencil, one first point, one second point. Okay. Now, we will take help of scale. Now, we will keep these pins apart, and now with the help of scale, what we will be doing, we will be joining these 2 points and straight to the emerging side of the glass slab. So, we have done this thing, just done. Okay. Now, at the point of emergence also again we will be drawing another normal perpendicular to the surface of emergence. This normal we should be also drawing by dotted line. Done. Now, this point, the point of incidence and this point of emergence, these two points will be joining simply with the help of a scale. Join. Now, what is the foremost and important thing in ray optics? You have to give the ray always. Do not forget to give these arrows. Okay. Now, as you can see, this is the incident ray, this is the refracted ray inside the glass slab, and this is the emergent ray which is coming outside the glass slab. Now, what we will be doing, this was the actual path, this was the actual part of the incident ray. Now, ultimately you can see the ray got shifted a bit. So, what we will be doing, we will be drawing the actual path with the help of a dotted line once more. Now, see this thing students, if glass slab would have been not there, this ray, this incident ray would have been going like this straight path, but due to presence of that particular glass slab over here, what we are seeing that the ray is getting shifted a bit, it is getting shifted. Now, this emergent ray and the ray which we have extended, these two rays are parallel, and this shifting, how much shifting is happening over here, this shifting is called lateral shifting, this shifting is called lateral shifting. Now, what is our next task? We have to find this particular angle with the help of protector, this is called angle of emergence, and we have to find this particular angle with the help of protector, that is called angle of refraction. So, angle of incidence already known to us, that is 30 degree, angle of refraction we will calculate, and angle of emergence we will calculate, and we will put in the table as I have discussed earlier. Okay. Now, with the help of protector, what we are doing? We are finding the angle of emergence. First, we are finding the angle of emergence. Now, see student, already I have told that angle of incidence is 30 degree, and for this particular thing I am getting the angle of emergence very nearly 30 degree, that means almost I am getting 29.5. You can see from 90 degree I am starting, it is coming very near to 29.5 degree. That means my level of practical is almost to the accurate result. So, I should be getting 30 degree exactly, but I am getting 29.5 degree, very near to the accurate result. So, this I have to note down. During practical, this kind of minute error can happen. So, this you have to consider also, this kind of practicals error you have to consider, and you have to take the reading by that way only, and we will be calculating the angle of refraction now. Okay. Now, as you can see here, when I am putting this protector here, angle of refraction is coming almost 10, 20 and nearly 22 degree almost. Okay. So, what you are getting? Nearly 20, 10, so from here you have to start 10 degree, 20 degree, and this particular ray you have to extend. So, this is coming almost nearly 24, 25 like that. Okay. So, this is the point. Okay. So, this angle of incidence 30 degree, angle of emergence we are getting 29.5, and angle of refraction is coming almost 24.5 degree. So, in this way the same thing we will be repeating for more angles. Now, we will be doing for 45 degree, we will be doing for 60 degree, corresponding angle of refraction and angle of emergence we have to calculate. Rectangular glass slab, for different angle of incidence, measure the angle of incidence, angle of refraction and angle of emergence. Now, here what we are doing? We are taking a glass slab. Now, this glass slab, what we are doing? We are taking incident ray falling on the glass slab, and this point, this at the point of incidence we are taking a normal. Now, this angle, as you all know, this angle is called angle of incidence. Now, when the light ray is entering from rarer medium to denser medium, or refraction is happening at the point of incidence, the ray of light is bending towards the normal. This particular angle which we are getting with the refracted ray with the normal is called angle of refraction. Now, this ray again on the falling on the second surface is coming outside, this ray which is coming outside is called the emergent ray. Now, this emergent ray is also making an angle with the normal draw at the surface of emergence. This particular angle is called angle of emergence. Now, we know this thing that angle of incidence and angle of emergence are equal. Why? Because these two rays are parallel. As these two rays are parallel, and if we extend this thing, we will be getting a shifting. This particular shifting is called lateral shifting. That means, this extended incident ray and this emergent ray, they should be parallel. So, to prove them parallel, we should be getting this particular angle and this particular angle should be equal. So, that practicals we are doing, and we will observe this thing that they are coming equal or not. Now, for this particular thing, what requirement, what apparatus we require? We need a glass slab, we require a board, a white page, some long pins are required. The long pins we will be putting at these 2 points, and that we will be observing through this point, particular point, through the glass slab. So, what will happen? There will be shifting in the position of the pins when we will be observing through this side. So, that shifting we will be observing, and another 2 pins will be taking help, and we will be putting in this particular position to see how much deviation is happening for the ray. Now, for this particular experiment, what we need? We need a table. A table we will be showing on that side of the board. Now, let us come by the same process. We are repeating this particular practical for 30 degree already we have done. Now, for again angle of incidence 45 degree we have done the same thing, and again for 60 degree we have done the same thing. Actually, we are taking 3 readings so that we can take the average value and we can conclude our result. Now, for that particular 45 degree and 60 degree, as you can see, the emergent rays are shifting, emergent rays are getting shifted. For this thing we are getting angle of emergence particularly for 45 degree, and again for 60 degree again another angle of emergence we are getting. Corresponding angle of refraction also we are getting for 2 different values. So, total this all the 3 readings has been taken in our observation table, and ultimate conclusion we will be doing. According to the observation what we have taken just now, what we are getting for the first angle of incidence 30 degree, we got the angle of refraction to be 24.5 degree. Corresponding angle of emergence was coming 29.5 degree. Now, as you can see, angle of incidence is 30 degree, angle of emergence is coming 29.5 degree. So, difference between this one is coming 0.5 degree. This is for our first reading. Now, we have repeated the same process for 45 degree. For 45 degree, we are getting angle of refraction to be 36 degree, and for that thing the corresponding angle of emergence is coming 45 degree. So, angle of incidence and angle of emergence is exactly same. So, difference is becoming 0 degree. Last one we have taken for 60 degree. For 60 degree, we are getting angle of refraction to be 46 degree, and angle of emergence is again coming 60 degree. So, see here also 60 degree and 60 degree both are exactly same. So, difference is coming 0 degree. So, ultimately from the exact from this total observation table, what we can tell that angle of incidence and angle of emergence for a particular glass slab, whenever we are doing this practical, they are coming 0 degree averagely. So, that means what is happening, angle of incidence and angle of emergence as they are equal. So, we can conclude this thing that incident ray and the emergent ray are parallel to each other.